truth tables. This is solely a section on us going over what is a truth table and what are the symbols in truth tables that allow us to read them. So there's going to be some areas in which we're looking at these and going, I'm not really quite sure what these symbols mean. And that's exactly why we're going over this right now. So we can see that there looks like an S, V, squiggly line, R. Well, we already know that the squiggly line means opposite or whatever R was. We saw that with our conditional statements for inverse, converse, and contrapositive. So that just means the opposite of whatever that statement was. And these are two statements right now. For example, like when we're looking at this phase 1 area, we can see this is pretty simple. It's very basic. That's why it's in phase 1. You can see it goes all the way up to phase 4 where it gets more and more complicated. And that's going to hold true. It will get more and more complicated, but we're just learning how to read these right now. So R, it would be a hypothesis, and S would be a conclusion. Then it moves over to another column where we see that SVR. Now, the V in between the S and the R is actually not a V. That is actually a down caret. That's a down arrow. And then there's also going to be an up arrow. And I have both of those definitions provided in pink right there. So whenever the arrow is down, it's saying that A, V, B, or A down arrow B will be false if A and B are false. So whenever we look at this simple table right here, you can see that in order for SVR, or S down arrow R, to be false, it would require R and S both to be false, which is why whenever we're looking at this, you can see that the only one that turned out to be false was the one that was both R and S are false. Now, if it was S up arrow R, then it would require both R and S to be true for it to be a true result. So the only one that would hold true if we were to rewrite, instead of SVR, we did S up arrow R. Only one that would be true for this would be right here. Only those two statements are both true, meaning that it's a true statement. So reading these tables is very strange, and it's going to be something that you need to get used to, but the two definitions that are written in pink are the things that you need to know. Let's take a look at an example. You can see that this one has the upward facing arrow, which means that if Q and R are both true, then Q up arrow R will be a result as a true statement. So they both have to be true. So this is why this is going to look like, okay, the only one I see true statements on across Q and R is this one. That means that's true because both Q and R are true. And the only reason I know that is because of that arrow right there. It's pointing up. That means both must be true in order for it to be a true statement. So up is positive. I associate that with positive as being good, so true. And then down would be both being false. It makes her false. So that would leave the remaining answers as, well, they're not both true, so it's false. They're not both true, so it's false. And they're not both true, so it's false. Obviously, if Q and R are false, then the answer would be false. And you can see how this is just basically creating a logic table based on what's being asked. And what's being asked is this symbol right here. That's telling you what kind of comparison you're making between a hypothesis and a conclusion.